Graphical computer interfaces look great when things are running smoothly, but if you open a server log containing millions of rows, the visual application can easily become overwhelmed, leaving you with a frozen screen. Underneath that graphical layer sits the raw operating system. It was built to operate entirely through text, a method designed to handle high-volume data without the overhead of a visual interface. Today, we will bypass those visual limitations. We are going to take a chaotic server log and use specific text commands to extract critical security errors. To follow along, open your terminal emulator if you are on a Mac or Linux machine. If you are on Windows, boot up your Windows subsystem for Linux environment. You will also need to download the sample log file linked below. Our objective is to move away from clicking through menus and learn how to interact with the system's raw data directly. The command line mirrors a visual file window. Type pwd to print your working directory. Next, type ls to list your environment's contents, perfectly matching standard graphical folders. Finally, type cd and a folder name to step one level deeper. Be careful with your spelling. Linux environments are case-sensitive. If you type a lowercase l for a folder named logs with a capital L, the system will report that the destination does not exist. You can avoid typos by using the tab key. Type the first few letters of a folder name, hit tab, and the terminal will automatically complete the rest of the name for you. Navigating by text relies on the same spatial logic as clicking through visual folders, but it allows for much greater precision. Our folder holds a massive log file. Printing that entire file to the screen all at once would create an unreadable wall of scrolling text. Instead, we can safely preview the data using the head command. By typing head-n10 followed by the file name, the terminal will display only the first 10 lines of the log. If you need to read further without loading the entire file into system memory, use the less command. This opens the log in an interactive viewing mode, allowing you to scroll downward one page at a time. Once you finish reading, you will notice your command prompt has disappeared. To exit this document and return to your terminal, simply press the Q key. These tools ensure you can inspect any file size without crashing your terminal session. A safe preview confirms what the data looks like, but manual scrolling will not help us locate a specific error buried 40,000 lines deep. To find targets, use grep. Type grep, critical, and the file name. The terminal filters the torrent, pulling out only the lines containing that word. Standard editors struggle to search a file this large. grep achieves the result immediately by utilizing the system's raw processing speed. In a fraction of a second, the irrelevant noise is removed, leaving us with isolated, actionable data. Right now, those filtered results exist only temporarily on your screen. If you close the terminal, the data vanishes. Hit the up arrow key. This recalls your previous grep command, saving you from retyping the entire sequence. Add a greater than symbol and type criticalerrors.txt to redirect the output. Instead of printing to the screen, it creates a new document. A single arrow overwrites existing files. To safely append new search results to the bottom, use two arrows. Output redirection is the bridge between temporary analysis and permanent evidence gathering. We now have an evidence file sitting in our log folder. To keep our environment organized, type make directory for make directory, followed by the word evidence. Next, type mv, then criticalerrors.txt, and finally the name of our new directory. This transfers the file into the clean evidence folder. Run the ls command one more time. You will see that the log directory is clean and your evidence is stored safely in its own folder. Verify the move by typing cat evidence/criticalerrors.txt. This prints the final, curated file to the screen. You have successfully navigated a file system, filtered through thousands of irrelevant lines, and secured your findings in a dedicated report. All of this was completed in minutes without ever needing a mouse. Our evidence is isolated, but right now any user on this system could read it. To lock this file down, we need to apply specific Linux file permissions. We will secure the folder in the next lesson.